Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 9th lesson on a given Form 4 mathematics topic called integration. So we are looking at our fourth aspect on this particular topic, which is called applications of integration in kinematics. So we start by defining the term kinematics. So kinematics is simply a branch of classical mechanics that deals with motion of bodies with special emphasis on geometric aspects of motion such as position, velocity, and acceleration. So we are looking at our 12th example, which is a past cases equation tested in 2015, paper 2, question number 22. It reads that a particle was moving along a straight line. The acceleration of the particle after t seconds was given by 9 minus 3t meters per second squared. The initial velocity of the particle was 7 meters per second. Find part A of the question, the velocity of the particle at any given time t seconds. So of course we start by highlighting the key information that we are given on the question. So we are told that the acceleration is given by 9 minus 3t. Therefore, we are given the acceleration which is equals to 9, then of course minus 3t. Now the question wants us to find the velocity of the particle at any given time at t seconds. So they want us to get the velocity v. Now remember, we said that the formula connecting acceleration and velocity is the formula for acceleration, which states that acceleration A is equals to the change in velocity, that is dv, divided by the change in time, which is dt. So from this equation, we are going to substitute the values that we have from the question. So from the question, we are given 9 minus 3t as the acceleration of this particular body. Therefore, it means that our acceleration, which is equals to dv over dt, of course, will be equal to the A is given as 9, then of course minus 3t. Therefore, if I want to get the velocity of this particular particle at any given time t, of course, I'm going to work out this particular equation here. So clearly, dv over dt will be equal to 9, then of course minus 3t. So because we need to find the velocity v, I'm going to make a dv to be the subject of my formula. Therefore, for me to achieve that, I'll multiply both sides of the equation by dt. I also multiply this equation by dt. So clearly the dt and dt will cancel out. So that means we are going to remain with dv being equal to 9, then of course minus 3t, then of course this is multiplied by our dt. Now remember, we said that any multiplication by dt or dx, that one is telling you to integrate. Therefore, we are going to integrate both sides of this particular equation. So the integral of dv will give us v, which will be equal to the integral of 9. Of course, this one means that it was 9 t to the power of 0, because we are integrating with respect to at the time t. Therefore, if we integrate this term, we're going to have 9 t to the power of 0. When you integrate, you add 1 to the power, then of course divide by the new power. Then of course minus, it means this was 3, that is t to the power of 1. So this will be 3 t to the power of 1. Then of course we add 1 to the power and divide by the new power. Then whenever you integrate, you have to add an arbitrary constant of integration, c. Therefore, it means that the velocity of the particle at any given time t was given by, so this is 9, then of course t to the power of 1, then of course over 0 plus 1 will get 1, then minus 3t to the power of 2, then of course divided by 2 plus a constant of integration. Therefore, the velocity of the particle at any given time t will be equal to v is equals to, we are going to have 9t, then of course minus 3 over 2 t squared, then of course plus c. Now this is the velocity, then of course we still have the constant, but remember from the question we are given that is the conditions to eliminate our constant of integration. Therefore, we are told that the initial velocity of the particle was 7 meters per second. Remember, we said the word initial means that the motion has not started. Therefore, initially, we'll say initially the time is equals to 0 when the velocity of the particle was 7 meters per second. So initial conditions means that the time was equal to 0. Therefore, if I substitute in my equation here, I'm going to have the following. So my velocity is 7 meters per second. So this will be 7 being equal to, then of course 9 into, the initial time is 0. So this will be t is 0. Then of course minus 3 over 2. Then into our t is still 0. Of course, then it was t squared. Then plus the constant of integration. Therefore, this will be 7 is equals to 9 by 0. We'll get 0. Negative 3 over 2 by 0 squared. We'll get 0. Then, of course, plus c. So, clearly, the value of the constant c will be equal to 7. Therefore, the velocity of the particle at any given time t will be given by v is equals to 9t, then, of course, minus 3 over 2, t squared, then plus the constant of integration c, which now is equal to 7. Therefore, this is the velocity of the particle at any given time t. Then we check part B of the question, whereby we are told to find the maximum velocity of the particle, the maximum velocity of the particle. Now, remember we said that at maximum velocity, at v maximum, or what we call at maximum speed, at maximum speed, we had already alluded that at that particular point, the acceleration of the particle, which is a dv over dt, must always be equal to 0. Remember, when we are at maximum velocity, usually the dv is always equal to 0. That is, there is no change in velocity. So if a is equals to dv over dt, and of course our dv is 0, we will have 0 over dt, which will yield 0. Therefore, the key thing to note is that at any given maximum velocity or at any given maximum speed of the body, the acceleration of the particle must always be equal to 0. Therefore, we already have the equation for acceleration, which was given as acceleration was 9 minus 3t. So this one is equals to 9, then of course minus 3t. So because at this particular point, the acceleration must be equal to 0, therefore it means that a, which is equals to dv over dt, which is equal to 9, then of course minus 3t, this must be equal to 0. Therefore, if I pick the second part of the equation, this one here, clearly I'm going to have 9 minus 3t being equal to 0, which means that 9 will be equal to a positive 3t. That is, I've taken this one on the other side. So I divide through by 3, clearly the value of t will be equal to 3 seconds. Therefore, it simply means that when the velocity of the particle is maximum, so we are saying that at Vmax, at the V maximum, t is equals to 3 seconds. So when the velocity of the particle was maximum, the time at that particular point was equal to 3 seconds. Now that we have the time, and remember we already have the equation for the velocity, so the velocity of the particle at any given time t was given by this equation here, which was 9t. So the equation for velocity was 9t, then of course minus 3 over 2t squared, so minus 3 over 2t squared, then of course it was plus 7, which was our constant. Therefore, the velocity of the particle at a time, that is at the point when time is equals to 3 seconds, will be equal to 9 into 3 seconds, then of course minus 3 over 2 into 3 seconds squared, then of course plus 7. So this will be equal to 9 by 3, I'll get 27, then of course minus 3 squared is 9, 9 times 3, I'll still get 27, then of course over 2, then of course plus 7. I feed this on the calculator, 27 minus 27 over 2 plus 7. My calculator will give me 20.5 meters per second. Therefore, the maximum velocity, that is Vmax, will be equal to 20.5 meters per second. Then we check part C of the question, whereby we are told that to find the distance covered. Remember, distance is s, covered by the particle by the time it attained the maximum velocity. Remember, the particle attained the maximum velocity when time was 3 seconds. So we are simply going to find the displacement of the particle, or the distance of the particle, when t is equals to 3 seconds. Therefore, we're going to have the following. So remember, we already have they want us to get s. So to get s, we shall need a formula connecting s and v, because remember, we already have the equation for v, which was equal to, the v was 9t minus 3 over 2t squared. So this was 9t, then minus 3 over 2t squared, then of course plus 7. Now we want an equation for the displacement of this particular particle, or simply the distance or the height of this particular particle. Now, of course, the formula connecting s and v is the formula for the velocity, which states that the velocity of the particle must be given by ds over dt. So, of course, this velocity will be equal to, we already have the equation here, which is 90 minus 3 over 2 t squared, then of course plus 7. So I'm going to pick the second part of the equation, that is this particular part here. So it means that ds over dt will be equal to 9t minus 3 over 2t squared, then of course plus 7. For me to get the value of s, I first of all need to remove the dt from the denominator. So dt and dt will cancel out. So clearly ds will be equal to 9t, then of course minus 3 over 2 t squared, then of course plus 7, then it is being multiplied by dt. Remember, we said that any multiplication by dt, that one is telling you to integrate. So because we are multiplying here by dt, we're going to integrate both sides of the equation. So the integral of ds will give us s. So we'll have s being equal to the integral of 90. Of course, this is power 1. It means it will be 90 to the power of 1. Then, of course, we add 1 to the power and divide by the new power. Then minus 3 over 2 t to the power of, I'll add 1 to the power. So this is 2 plus 1. Then divide by the new power, which is 2 plus 1. Then, of course, the last term is 7. It means it was t power 0. So this will be a plus 7 t to the power of 0. Then, of course, I add 1 to the power and divide by the new power. Whenever you integrate, we add the constant of integration. Therefore, s was equal to, s is equals to 9t to the power of 2 divided by 2, then minus 3 over 2, t to the power of 3, then divided by 3, then of course plus 7t power 0 plus 1, I'll get 1 divided by 1 plus c. So clearly s will be equal to 9 over 2 t squared, then of course minus 3 and 3 will cancel out. So we'll have 1 over 2 t to the power of 3, then of course plus 7t plus our constant of integration. Now, for us to get the constant of integration, we're going to apply the initial conditions. So we'll say initially, remember, initial condition states that t must be equal to 0 when the displacement of the particle is 0, because the motion has not started. Remember, whenever you're not given any conditions to remove the constant, we usually revert back to the initial conditions. Like in this case, we are not given any conditions involving the displacement s or the distance s. Therefore, we use the initial conditions. So t is equals to 0 when the displacement is 0. That is when the body has not started its motion. Therefore, if I substitute here, I'll have s, which is being equal to 0, being equal to 9 over 2 into t is 0 squared. Then, of course, minus a half into 0 cubed. Then, of course, plus 7 into 0. Then, of course, plus c. Therefore, 0 is equals to, this will give us 0 minus 0 plus 0 plus c. So clearly, the value of c will be equal to 0. Therefore, it means that the equation for s would remain to be 9 over 2 t squared minus a half t to the power of 3, then of course plus 7t, then of course plus 0. But adding a 0 does not change the equation. Therefore, this is the equation for the displacement of the particle at any given time t. Now, the question wants the distance covered by the particle by the time it attained the maximum velocity. Remember, when the particle attained the maximum velocity, we already have the time. So we've said that at maximum velocity, at Vmax, the time was equal to 3 seconds. Our time was 3 seconds when the particle was at maximum velocity. Therefore, the displacement when t is equals to 3 seconds will be given by the following. So I'll just substitute in the equation for the that is the displacement of the particle or the distance of the particle. Therefore, s when t is equals to 3 seconds will be equal to, so we're going to have 9 over 2t squared. So this is 9 over 2. Then our t, of course, is now 3 squared. Then, of course, minus a half into our t is 3 cubed. Then, of course, plus 7 into our t, of course, is 3. Therefore, this will be equal to 9 over 2 into 3 squared. Of course, that is 9. Then minus a half into 3 cubed. That is 27. Then plus 21. So this will be equal to 9 by 9. I'll get 81 over 2. Then minus 27 over 2. Then, of course, plus 7 by 3. We got 21. So we feed this on our calculator. We'll get s at t is equals to 3 being equal to 81 over 2 minus 27 over 2 plus 21. Our calculator will give us 48 meters. Therefore, the displacement of the particle when the particle was at maximum velocity s was 48 meters. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you're new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.